Um, okay, so I wanted to talk a little bit about what's possible in urban farming. We tend to kind of, in my mind, underestimate what we can actually do in urban farming. So, to get started here, let's start with a really important question: how do we disrupt the multi-trillion-dollar industrial food machine? And really, uh, kind of jumping into that, why do we want to disrupt that industrial food system? The first thing is there's a number that's been bantered around a lot. This was a number that was based on a study done by the Food and Agriculture Office through the UN, that we have, considering the way that we are currently producing our food, we only have 60 years of agriculture left. And so the first question is, do we actually have 60 years of agriculture left? And really, the answer to that is no. First of all, the study was done in 2014, so we're at 53, but nobody ever seems to count that one down. We just keep moving the 60 years forward. But the other thing that's really important about that is that our food production system is a system. It's not a hopper. So, if it was a hopper, we would just, it's full. We have 60 years worth of food in it. We keep taking full draws until it's empty, and that's not how it works. What's going to happen is that as we move along with the degradation that we're doing to our soil, as we start losing productivity, we're going to get closer and closer to famine every year. And so that's something that's very, very urgent. It's something that, if you look at the social movement, it typically takes about uh, 3 generations to really make it a part of the culture. And we don't have 3 generations. We have 1 generation. We need to make this happen right now. So that's very urgent. So then another one is growing food with toxins, and the toxins that we use to try and go against the natural processes. We basically just we're poisoning everything, and unfortunately, those poisons end up in our food. They end up in our environment. They're causing environmental damage. They're causing health problems with us. And that's something we definitely need to take into account. We have the issues of falling nutrition. So the nutritional profile of the food, according to one study I saw, it was something like 70% of the nutrition in our food has been lost just in about 50 years. And so if you want to get the same nutrition, if you want nutrition density, you end up having to eat more food, and our health suffers because of that. Then, of course, there's the carbon footprint. Everybody is pretty aware of the carbon footprint of industrial meat, but industrial vegetable production is really just as bad. Every time we till the soil and we apply those fertilizers, and the transit that happens as we're in some cases eating food that was grown on the other side of the world. These things all have just an enormous carbon footprint. One of the other big issues is resilience. So we saw the this year really the cracks in how resilient is our food supply. Do we have food security? And all it took was a pandemic, and I know that's all it took, but the pandemic really disrupted our food supply. I mean, we've been almost a year into this now, and I still go to my local grocery store and there's empty shelves because we just can't pull together what we need to fill those shelves. And as people get to really understand what's going on with their food supply, they want to know what they're eating. They want to know what they're putting in their body, and so they demand transparency. And because it is a multi-trillion-dollar organization or industry, they actually have politicians in their back pocket, and anytime the public calls for bills requiring transparency in the food supply, the industry lobbyists come forward and they say, no, 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 we don't want to do that. In fact, let's go ahead and put in a bill that there's some places it's actually illegal to list whether something has GMOs in it, for example. And so they're actually trying, using that political power that they have, by how we buy our food, to reduce the transparency. So, what's the answer? Local food production is the answer. You know, if you want to really dig into transparency, the best way to get true transparency is to know your farmer. If you've met the person, if you visited their farm, it's true transparency. You know where your food was created. There's not layers of obfuscation in there. And regenerative food production is the answer as well. If we actually create something, and so let me make a little bit of a distinction for you here right quick. So sustainable, we talk about sustainable agriculture quite a lot. And um, when, you know, if it, sustainable is, it means sustaining it. It means keeping what we currently have. And the problem with that is that what we have is already in an advanced state of degradation. We need to make it better. We need to restore it to where it was. We need to regenerate it. But the question then is, can we do local and regenerative? So let me back up just a little bit. I want to talk about what is a regenerative agriculture. So regenerative agriculture is something that regenerates the environment. It does that by having a complete ecosystem. So that includes plants, that includes soil, that includes fungus, that includes animals. These things are all vital, absolutely important parts of every ecosystem on the planet, and they all need to be there fulfilling the role that they do. In order to do that, though, you tap into the abundance of the natural ecosystem, and so it creates out of that abundance. It creates food for people, but in doing so, it builds the soil. It builds living, very biologically active soil that's going to actively sequester carbon, and it creates habitat so that you have the wildlife that's going to come in that's representative of your area and integrate with that and be a part of it and help build that biodiversity. Uh, but there's some challenges with regenerative agriculture too. The first is that it's management intensive. It's something that you have to really get in there and have a hands-on approach and really understand how all of the different pieces fit together and how to manage them the best way that you can. And to do that, you need expertise. You have to actually understand what it is you're doing, or you're gonna have some unintended consequences. Of course, the other problem is that it requires space. If you want biodiversity, you need to have a big enough environment to have some level of biodiversity. So the question then becomes, how do we bring regenerative agriculture into urban areas? And to really start to answer that question, I want to back up a little bit and start with a very different question. In this case, it was a question that was asked by a 12-year-old boy who didn't want to clean his lizard's cage. And you know, this little boy realized that out there in the forest, nobody's cleaning up after the lizards. It's all handled automatically. And so he wanted to kind of understand why he has created something where he does have to clean up after the lizards. And the question that was asked was, who can do this that isn't me? And it turns out that this is actually a really, really important question that takes you on a very, very interesting journey. And I wanted to kind of take you guys on a journey of discovery of where this question has led. And as you might imagine, the you probably figured out that 12-year-old boy who was too lazy to clean his lizard cage. That was me. Um, and what I started with was creating terrariums. I created a little forest terrarium. I created desert terrariums. I created bog terrariums, but each one was designed. This one here is kind of a mixed water and forest terrarium. Um, and I created, the goal was to design an ecosystem around the life that was living in the terrarium so that the inputs and outputs matched each other. And it took me definitely in some interesting directions. As I moved towards my late teens and went off to college, I went to Georgia Tech, to study engineering, and I learned some really kind of valuable pieces in engineering school. The first is really understanding what the engineering thought processes are. How do engineers think? How do they solve problems? It turns out you can actually use some of those thought processes in designing and creating ecosystems. The second thing that I learned is the difference between science and engineering. And the really important piece there is we as a society hold science in very, very high regard, as we should. It's very important. Um, but we try to use it to solve every problem. And science at its heart is a a method for gathering information. If you want to actually use the information, it's actually engineering that we use to do that. The science and engineering are two sides of the same coin, but we need to kind of flip that coin over sometimes. And the really big difference is if you break it down, the science is a reductionist process. You break it down to its component bits so that you can study it in detail and really understand what's going on. But then, especially with something like an ecosystem, you have to put those bits back together. They don't exist in a vacuum, and that's where the engineering thinking, the engineering problem solving mindset comes in. The other thing that I learned in engineering school was that there really isn't an established branch of engineering for ecosystems. Um, if you look at, there's a couple of branches of engineering that kind of get close, but in terms of like actual ecosystem engineering, it doesn't exist. And one of the things that I've always found interesting is that if you look at electrical engineering. Electrical engineering basically comes in designs with electromagnetism, and we are having this conference right now because of the work of electrical engineers, the things that they built out of those basic processes. And if you look at some of the problems that we've had with sustainability, in terms of pollution, in terms of climate change, in terms of just about everything that's going wrong in this world, these are all things that are a fundamental breakdown of the ecosystems that manage this planet. And so, ecosystem engineering should be every bit as ubiquitous as electrical engineering, and it just isn't. It's something that we really definitely need to work on. So, moving on into my early 30s, I picked up gardening. First thing I did is I said, okay, you can't build an ecosystem if you're poisoning everything. So learning and organic gardening was a really important step there. One of the things that's a really important piece of that is understanding composting. There's a bunch of different methods of composting, and they all have their pros and cons. But one of the ones that really kind of jumped out at me was vermicomposting, and that's the use of earthworms to really create a high quality soil out of the waste that a household produces. One of the other systems that particularly struck my eye is something called hugelkultur, and that's the process of burying large amounts of wood in your soil to create systems of life, kind of a lasting food supply for the soil organisms. It's something that at its heart says soil organisms are our pets. We take care of them. We feed them. You have to feed your soil. And I think that was something that was really, really valuable about hugelkultur. Moving into my 30s farther, I picked up, as I tried to understand more about what was going on in those environments, I picked up mushroom growing. I studied the work of Paul Stamets. And the first thing that really caught my mind on that was an article that he wrote where he's talking about wood chips and the process of composting wood chips. So if you take your wood chips and you dump them in a compost pile, they're going to cook pretty slowly. They'll turn into compost, but it'll take a couple of years, and you get good quality compost. But it's a slow process, and all you get out of it is soil. Um, However, if you take those wood chips and you grow mushrooms on them, and then take what's left and compost it, you still get the same soil. You actually get slightly better soil. It gets to soil much, much faster. But then you also get a product of value that comes out of that. You have food or medicine, whatever mushrooms that you chose to grow on those wood chips. And in studying some of the work that's been done with mushrooms, Mycoremediation was something that really jumped out at me. The mushrooms are really fungus is a pioneer species. It steps into damaged ecosystems, and you can use a process called mycoremediation to repair and remediate those sites back to a healthy ecosystem. And that's definitely something that is of interest. Mycofiltration is the process of filtering water, using the mushrooms to actually filter the water, and they'll take chemicals out of the water, they'll take nutrients out of the water, they'll take bacteria out of the water. The mushrooms are actually really, really effective at doing that. Um, and then, of course, understanding back to the wood chips to soil, starting with the mushrooms on the wood chips, and then if you actually put earthworms on the 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 spent mushroom blocks, you get a process called mycovermicomposting, where you're using a succession, and you actually, from that standpoint, can get from wood chips to really rich, healthy soil very, very rapidly. And just a really neat process. So, moving into my late 30s, I started to study aquaponics. And aquaponics is something that, hydroponics is something that was never of particular interest to me. I am at my heart a soil guy, and to me, something that removes the soil entirely um, from the system is something that maybe doesn't understand what's going on, because value soil has just absolute immense incredible value, and aquaponics I think falls into some of those same traps, but at the same time aquaponics is something that is it has its own value, and I liked particularly the fact that it's a closed loop system. It does have the animals mixing with the plants, um, and in studying aquaponics, I learned a little bit more about the mechanical systems that run that and keep it running, and I really like the efficiency gains of aquaponics. And so, moving into it, in my early 40s, I moved to Phoenix, Arizona, and realized that I wanted to do gardening, and I know myself well enough to know that I'm going to be a really great gardener. I'm going to be on top of it, absolutely 100% for about 3 weeks at a time, and then I get distracted. I get busy. I get off on a project. I get off on work stuff that's got me running all over the place, and I will just walk away from my garden for days at a time. And you can't do that in Phoenix. It's got to be cared for all the time. And so as I started to try and figure out how to design something that would kind of automate that process for me and take care of it for me, I started, kind of thinking through what I understood, all of these concepts that I had learned over the years. And I started with another question. And that question was, can you do aquaponics with soil? And to do that, this was my first system here. The bed I actually originally had a little aquaponic system here, an actual true aquaponic system. And one of the things that I found, I was just constantly struggling with the pH of the water, because we have a high salt content in our water here, and it just builds up over time. And so I was adding about a gallon a week of hydrochloric acid, just in an attempt to keep my, the pH of the water was trying to climb over 9.0, which is just entirely hot, too high for living systems. It's very alkaline. And so when I first built the soil here, I said, okay, I know how to make soil. I understand the different processes. So I just put whatever I had in there. I put some finished compost. I took apart some container gardens that I had and put the soil in there. I added some leaves from around the yard, and I had a couple of spent mushroom blocks. And I figured, okay, this counts as hugelkultur. They should break down pretty quickly because they're done making mushrooms. So I put those into the garden. And really, I got some surprising results from doing this. The first surprising result that I got happened within 48 hours. That pH, which was somewhere at that time between 8.5 and 9.0, dropped within 48 hours to 7.0, and it stayed there. It kind of settles out at about 7.5. But in the 8 years that I've been doing this, I built this first system in June of 2013. I've almost never had to add any sort of acid to the system to try and bring up the pH. It's just something that the biology in the system handles that for me. Which is actually something that is a lot of work in aquaponics. The second surprising result happened in October of 2013. So this garden sat in full sun all summer long through the brutal heat of a Phoenix summer, and when October hit, the temperatures dropped. We got a little bit of rain, and all of a sudden, those mushroom logs that hadn't produced anything for 6 months started growing mushrooms. There was apparently enough life in them, and the garden itself ended up being a life support system for those mushrooms, created the conditions that they needed to grow, and bam, I started getting more flushes of mushrooms out of these logs. And that was something that really kind of opened my eyes to what was possible here. And then on the third surprising result happened in um, June of the next year. Again, June's our hottest month. It's the temperatures can be 115 degrees Fahrenheit, 120 degrees. It's just ludicrously hot, and in doing that, it's so I ended up having to go on a business trip, or I was going to be gone for 2 weeks. I didn't have anybody who could watch my garden for me, who understood what was going on and could actually take care of it. So I asked somebody to just stick their head out 3 times a week. Is anything running dry? Is anything overflowing? Is everything dying? And literally, the garden didn't get touched for 2 weeks in the hottest part of the year. Everything did fine. The thing just sailed straight through the month of June without any maintenance whatsoever. And that was something that really kind of opened my eyes as to what was possible and what was going on here. And so what I ended up doing was I named it a Lear garden. And so the Lear garden functions. So a Lear garden is itself a composting method. So it actually creates its soil in place out of the urban waste stream from the materials that we have on hand. And the basic concepts that are in place here, like I've kind of already run through them. So it starts with hugelkultur, the burying of the wood, and then you grow mushrooms on the wood, and the mushrooms break that wood down, and then the earthworms get in there and they turn that piece into soil. And then, since you have the water, you're recapturing the water and recirculating it. You put fish in the water, and you use some of those aquaponics concepts where the fish are adding nutrients, which will actually support the plants, which is the next concept through that soil creation process. And then the last one, because of the fish in the system, you can't spray it. You can't use toxins. You can't use fertilizers. It's something that's going to harm the fish. So you actually use biodiversity by interplanting herbs and flowers and a bunch of diversity of plants that draws in the biodiversity that exists in just about every ecosystem, even an urban ecosystem. And you'll find that the system, because of the health of the system, because of that biodiversity, manages its own pests and diseases. And a Lear garden, like I said, it says at the bottom, it's an acronym for linking ecosystem and hardware for regeneration. And that's really what it does. So it's using both the natural processes and the mechanical processes to make something that where everything just works together really, really well. So what comes out of this? Like I mentioned, it doesn't use any chemical inputs at all. The only real input is fish food. Like I said, it makes its own soil almost entirely from the urban waste stream. So in urban areas, we have a lot of tree trimmings, we have a lot of food waste, and those both go in really, really nicely to a Lear garden. It actually has an integrated compost bin that is a no-turn compost bin. It works better than any tumble composter I've ever had. A Lear garden produces soil as an output. It actually works best while it's making soil. So when it's finished, you take that soil out, you put it elsewhere, you work more material in, and the thing just keeps going. A Lear garden requires no daily maintenance, and people say, oh, no daily maintenance, so a couple times a week. Not really any weekly maintenance either. I typically spend there's a couple of big tasks that you have to do once or twice a year as you harvest the soil, but otherwise it requires maybe a couple hours a month. I don't consider harvesting maintenance. That's your benefit. Because it captures the water and recirculates it. Lear garden is low water use. And it's really super highly productive because of the healthy ecosystem. So here's just an example of one that I built. You'll note that these two pictures were taken, as I said, June is the hottest month that we have here. And 2020 was a particularly brutal year. We broke all kinds of records this last year on how hot it got here. And these pictures were only taken 3 weeks apart. So you can see just how fast it can grow if you give the right soil and the right water and create just the right conditions. And one of the things also about a Lear garden is it's very flexible in design. So here's a couple of different um, gardens that I've built using the same methodology. Just you can fit it to whatever system you're looking for. Um, so moving back to the our voyage of discovery, the next really important piece came in 2019 when I was invited to participate in a fellowship through ASU called the Knowledge Exchange for Resilience. And what the fellowship was about was looking at ways to improve resilience of urban areas. And there were a number of people all working in different areas. I was working on food. I was the only one person working on food production, but there were other people working on food distribution and stuff like that. And I learned some really interesting things about there. The first is really trying to understand what food deserts are and how they work. Um, and that was really helpful trying to design systems to do it. And one of the important things about food deserts is why they resist. There's a lot of people trying to fix food deserts, and they really resist being fixed. And that's a whole other talk there. But reach out to me later if you want to talk. It's a very interesting topic. One of the big issues, though, with local food production in urban areas is land use. The urban planners that kind of run everything and the zoning commissions tend to look at urban farms as something that just needs to be developed. And so they really push hard, even in an area where urban farming is slated as a priority. You get monetary incentives, you get zoning incentives, you get all kinds of things that are pushing you to try and uh, not have urban farms. And so one of the things that I found in studying actually the food deserts was that if you look in a food desert, especially particularly here in the Phoenix area, those food deserts have the people who live there have the same big backyards, but they don't have pools or landscaping in their big backyards. In a lot of cases here, it's just bare dirt because that's what they have the resources to do. So we actually have, instead of one big 5 acre farm, there's a resource there in an unused resource in the form of land, where you have an opportunity to create 1,000, 100 square foot or 500 square foot farms. Then you have uh, people, of course, in rural areas. If you're going to start a farm in a rural area, you get to be the expert on everything you do. But because there's a higher population density in urban areas, you can actually do some other things. There's kind of some interesting things that you can accomplish with division of labor, and particularly with creation of community. There's a lot of opportunities to create communities here. And the other thing that I run into as I start having this conversation with people is I always get this question: Will it scale? And I've kind of come to learn that what people are trying to ask is that industrial um, processes are so ingrained in our thinking that everybody feels compelled to ask. So the system that you've created to replace industrial agriculture, can we use it to turn it into industrial agriculture? And I think, I kind of resist the question. I think really the better question is, how will it scale? Again, instead of creating one 5-acre farm with a big old sea of Lear gardens, what if we create 1,000 farms in people's backyards? And then, the question again, it's like, how is that going to work? How do we bring regenerative agriculture into urban areas? And so let me kind of ask you, if you will, to use your imagination. So imagine, if you will, a house where you're living in an urban area. You've got, in my case, I have a sixth of an acre. Maybe you have a quarter of an acre. Someplace where urban sprawl, which is generally considered a bad thing, bad thing, might actually thrive and be potentially really, really beneficial. So you go into this lot and you go into your backyard and you build, say, a Lear garden. And uh, that Lear garden is going to manage, it's going to do the work for the homeowner. Of like, annual vegetable crops are a little bit more management intensive. And so you can get that Lear garden to do that work for you, and take care of it. So it's not really going to impact your daily routine, other than the fact that for dinner, instead of looking in the fridge, looking in going to the grocery store, you're going to go out in your backyard and say, okay, what do I have to pick? Um, and so you then have the opportunity to come along and say, okay, I have more land. I have a front yard, and you can landscape a food forest into your front yard, and you have perennial trees that really require pretty minimal care. You can even put them around the fridges in the backyard, and so you have fruit production of whatever is locally available, and you're eating seasonally with what your garden is doing. Um, and one of the things that happens is that you actually start producing a food as an output. So as that household, depending on what your dietary habits are, you may not produce everything that you're going to need. You're not going to have a cow. So if you like butter and cheese and meat, those are things that you're not going to be able to grow there, but you can produce more food than you can eat. And once you start creating abundance, that's when things start getting interesting, because you can take that food and you can sell it. We can, if we get lots of people growing this way, we can create markets around that abundance of food. You can share that food. You can give it to your neighbors, whatever makes sense for the person who's growing that food. But let's say, for example, this particular homeowner is going to sell that food. This is locally produced, organic, regeneratively produced food. And so, let's say that you make a couple of $100 selling this food. Okay. So now, that's going to help fund the initial creation of the garden. That's going to help have somebody who has some level of expertise come in, build the garden, plant your food forest, kind of help you with that expertise that each individual may not have on their own. But then you also start getting a community that can be created around this, where the individual homeowner doesn't have to propagate their own mushrooms to grow mushrooms in their garden. They can get somebody who's locally growing that and pushing it out to these gardens. The same thing goes with seed starting. If you can drop plants into the ground when planting season comes around, you can boost your productivity, you can boost your output, and you can have somebody who's starting those seeds. Again, part of that um, uh, uh, part of that ecosystem. You could even have somebody who's helping you maintain it. A Lear garden and a food forest, neither one of those things need to be maintained on a daily basis. You can do it at once or twice a month and keep everything going. And the benefits that you start to see are really, really cool, because you start to create an urban ecosystem. That's one of my favorite things when I build a new Lear garden, is watching all of the wildlife come in and see, hey, there's something here. You get little gnats and bugs, and the hummingbirds come in and eat them. And then you get some larger bugs, and the lizards will move in, and the birds will move in to eat those. And the beneficial insects will come in and they'll handle your pest problems. And it's just amazing watching this ecosystem form your garden. And the food forest is going to do the same thing. And that biodiversity is going to cause all kinds of really amazing side benefits. So, as you increase the plant cover, your air quality is going to improve. Um, One of the things that really helps is you can do rainwater harvesting and use the water that's naturally coming from the sky, which is going to help the hydrologic cycles, which are so broken in our urban areas. You got the cycle between, as you prune your food forest, you take those prunings, you chop them up, you work them into the Lehr garden. You take the soil, the finished soil out of the Lehr garden, you top dress it around your food forest. You're actually sequestering carbon. You're taking the carbon out of the atmosphere and putting it in the ground where it should be. And this is actually a really effective carbon sequestering technology. Some of the best, using living systems to put it into the ground is some of the best that we've found. And then, where you're creating, you're really reducing the urban heat island effect because you're increasing the plant cover, you're increasing the shade. And you're going to have all kinds of health benefits. You're eating food that is more nutrient dense, not just because it's fresher, but also because it was grown in really organic, biologically active soil instead of the degraded soil that we get out on industrial farms. It's something that you get to breathe. As there's a Dr. Zach Bush, one of his big bylines is "Breathe your biome." We need to breathe in that healthy or living ecosystem, and you can be a part of it because it's right there in your backyard. So let me go ahead and stop there. We've got a couple minutes left for questions here. Here's my contact information. Again, website. I'm actually working on creating a Patreon, and what that's going to be towards is really trying to get the information out there so that we can start these movements outside of the Phoenix area, so where other people can be building these systems and starting to kind of create this community. That's as I mentioned in one of the breakout sessions, creating that community, making a difference is really something that drives me, and is just a huge passion for me. So let me go ahead and stop it there. Unfortunately, I kind of ran a little late, so we've got a little bit of time for questions. So go ahead.
I have a question. This is really amazing. I think that system, it looks, I mean, my mind is kind of blown right now at how self-sustaining it is. I am wondering what kind of investment, both monetary and time commitment to get it started, are you looking at for one of these Lehr gardens?
It depends on the design. The bigger the system, of course, the more expensive it's going to be. It is, unfortunately, that's the one thing that I'm trying to see if we can find ways around. One of the things it's the one in my backyard. I spent, just in materials. I don't charge myself labor. It was cost me about $5,800 to put that together. If I was to build it for somebody else, it'd probably be around 11,000. But it's something, if we can start creating systems around this. That's one of the things I like about creating a whole system, is because if your business model is building gardens, then yeah, it's going to be pretty expensive. But then your business model becomes maintaining the gardens, and that's if you can charge a certain amount of money, and a lot of that gets offset by the output of produce, then your business model becomes about selling the produce, and you start taking that and say, well, we want to sell more produce, so we're going to actually reinvest some of those profits in lowering the cost of entry, and there become a lot of opportunities there. So yeah, unfortunately, that is the disadvantage at this point, but I'm trying to find ways around that, and I think as we can kind of create a whole economy around that, there's definitely opportunities. Let's see, we've got some questions in the chat. This is why land trusts are important. Yeah, like I said, feel free to follow me. I'm, Lehr Gardens on Facebook or Instagram. and Lear Garden on I don't have it I haven't got it live yet, but that should happen in the next week or so on Patreon. So um, yeah, let's create a movement. That's what I want to do.
Edmund, I have a question. I'm not sure if I call it. What is the smallest size that one of these gardens could be? I mean, could you fit it into an apartment, or how small could it be?
Well, I'm actually working on. I need to do my 3D modeling, but I've one of my partners has got a 3D printer, and we're actually looking to create a tabletop version of that, and some of the ecosystem really wouldn't be there. I mean, some of the little bugs and the gnats, you don't really want those in your house, and even earthworms. If you put earthworms in anything, they decide that sometime in the middle of the night that they're going to go for a walkabout, and so you find them dried up all over your floor. Um, but it is something that on a tabletop system will actually grow mushrooms and plants in the same space. So that's something I'm working towards. I've got a patio version that I build that's 2 feet by 4 feet and about 2.5 feet tall, that has the full functionality of it. So they can be built smaller, but you kind of have to design it carefully at that scale.
Thanks, I appreciate that.
Yeah. So I think we are to the end of our session, if I'm right, Mags. Um,
Yeah, we are there. Thank you for everyone for coming and joining. And I actually added my contact information in the chat. You can follow me on Instagram or send me an email. I'd love to help anyone out that has questions around, growing in urban agriculture continuously, because that is my calling. That's my path. And that's freaking. My mind's still blown with the Lear Gardens. I want one so much. Yeah.
I enjoy mine.
Unfortunately, I live in a condo, so apartment
Well,
one day.
I'm like I said, I'm working on developing the countertop version.
Yeah. So yeah, I will put a link for the main room. Just let me find it here. I don't know if you guys have it. Let's see.